In this next video, what we're going to move on to is finding the values of the six trig functions, but of very specific angles. So it's no longer going to be an unknown angle, but it's also actually going to be a very specific angle. And these angles are 30 degrees, 45 degrees, and 60 degrees. These are angles that are super common in math, and because of that, we want to know their exact values. So if we were to use a calculator, so for example, if I wanted to find the sine of 30, sure, I could type it into a calculator, or the sine of 45, or the sine of 60, but your calculator can only give you decimal answers. In other words, it's going to give you an approximate solution and not an exact solution. So we want to learn the exact solutions. These are really important going further in math as well. So this is something that you have to develop an understanding of. So I'm doing the table for you now, but you're not going to use this table to be for reference later. I want you to be able to use your special triangles to then replicate this process to always say, okay, well, if I have the sine of 30, I know how to draw the triangle. I know how to find the ratio of opposite to hypotenuse. So let's do it. So our first triangle that we're going to look at is our 30, 60, 90 triangle. Now what they've done is they've said, okay, every 30, 60, 90 triangle has the same ratio of opposite to hypotenuse, or opposite to adjacent, or adjacent to hypotenuse. And so they wanted to put these lengths that are always in the same ratio in lowest terms. So what they did is they started with a side length like 1. 1 is the smallest natural number you can get. It's your first counting number. So if you look at a triangle like 30, 60, 90, the smallest angle in this triangle is 30 degrees. So across from the 30-degree angle, they said that that side length is 1. Then they want to use the next smallest number, like a 2. And what they found is that if you put 2 as your hypotenuse, so as your longest side, you could then use Pythagorean Theorem to find this last side. So if we say x squared equals 2 squared minus 1 squared, I'd get that x squared equals 4 minus 1 is 3. And I get x equals plus or minus the square root of 3, which I'm just going to take as root 3 because these are just talking about lengths. And so they said, okay, well, the ratio of the sides in a 30, 60, 90 triangle will always be in a ratio of 1 to 2 to root 3. And so we use this as our base triangle. So what it is that if you type sine 30 into your calculator, you're going to get the same as if you go, hey, for 30 degrees, this is my opposite, this is my hypotenuse, and I get a half. If you, type sine 30 into your calculator, you get 0.5. What about the sine of 60? Well, for 60, same thing. I would go opposite over a hypotenuse, and I get root 3 over 2. And again, if you type into your calculator sine of 60, it's going to give you the decimal approximation of root 3 divided by 2. But we don't want decimal approximations. We want exact values. So this is the only way to get the exact value of these angles. So what I want to do is finish this chart for 30 degrees and for 60 degrees. So the cos of 30 would be adjacent over hypotenuse, or root 3 over 2. And the tan of 30 is going to be opposite over adjacent, or 1 over root 3, which rationalized would be root 3 over 3, right? Multiply top and bottom by root 3. Pause the video. I want you to find cos of 60 and tan of 60. So the cos of 60 is going to be from 60 degrees. Now the 1 is the adjacent, so it's a half. And for tan, it's going to be root 3 over 1, or just root 3. So what I want you to notice here is that when you change from a 30-degree angle to a 60-degree angle, you stayed in the same triangle, but the opposite and the adjacent sides switched. So sine switched with cosine, and tan switched with, or was the reciprocal of tan of 30 was the reciprocal of tan of 60, because the opposite and the adjacents flop. Okay, so they are related. They are part of the same triangle. So now we just need to learn one more triangle, because what about 45 degrees? 45 degrees is not in that first triangle. So if we look at the 45-degree triangle, again, we want our ratio of our sides to be in lowest terms. Well, the easiest number is a 1. If you know some rules about triangles, you'll know that when there's one 45-degree angle, the other one has to be 45, because angles in a triangle add up to 90. So if one angle's 90 and one's 45, the other one has to be 45. Because these angles are equal, the sides across of them have to be equal as well, right? If you picture kind of the mouth of the angle opening up, it will always open up to a certain size, you know, in scale of the entire triangle. And since these are both the same size mouths, they would open up to the same size side. So then if we use Pythagorean theorem again, this time we're finding the hypotenuse, it would be 1 squared plus 1 squared, which would be 2. So h squared equals 2, or h equals plus or minus the square root of 2. And again, we're just talking about lengths, so I'm going to say root 2. So your 45, 45, 90 triangle is a ratio of 1, 1, root 2. So now if I wanted to find the sine of 45 degrees, it doesn't matter which angle you're looking at. It's opposite over hypotenuse, or 1 over root 2, which is the same as root 2 over 2. And then cos is the same thing, because the adjacent and the opposite are the same. It's also 1 over root 2, or root 2 over 2. And then tan is opposite over adjacent, which is 1 over 1, or just 1. All right, so now I purposely put this at the end of a page, because now I want you to flip to the next page, and I want you to find the exact values of these functions without using what we just created, because I want you to create these triangles every single time. So in other words, for every single one of these questions, you're going to create a triangle with the angle down here being the one that you want to solve for. So same thing here. Sorry about my horrible drawing skills. Right, so this will be a 30. And then for this one, I know these should be drawn differently and I can't do it. And this one would be 60. So what I want you to do is in every single one of these triangles, I want you to put in, is it a 1, 1, root 2 triangle or a 1, 2, root 3? So 1, 1, root 2 or 1, 2, root 3. How do you decide? Well, the 1, 1, root 2 goes with 45, 45, 90. And the 1, 2, root 3 goes with your 30. So 30 degrees is your smallest angle. It gets your smallest side. 90, this is your largest side, which gets your largest angle. And 60, which is your middle angle, which gets your middle length side. So that's how you're going to fill them out. You look for the angle, and then you fill in the appropriate side across from it. So for this first one, it's a 45, which makes this 45. So it's going to be a 1, 1, root 2. For this one, it's a 30, 60, 90. So the 1 goes across from the 30. The 2 always goes across from the 90. And then the root 3 goes across from the 60. Okay, so now for this first one, we want to find the sine of 45. Well, the sine of any angle is equal to opposite over hypotenuse. So for this triangle, this would be the opposite. This would be the hypotenuse. So it would be 1 over, so the sine of 45 would be 1 over root 2, rationalized being root 2 over 2. I keep writing the unrationalized version because when we go backwards in a bit, it's going to be really important that root 2 over 2 is equal to 1 over root 2. Otherwise, it's going to get really confusing. Okay, so now what I would like you to do is I'd like you to pause the video and see if you can do the next two. Or maybe the next one and then watch the video again or whatever works for you. So for this one, maybe you pause the video and then you were confused right away, or maybe you went for it. This one is asking you for the secant of 30. So the first thing we should figure out is, well, the secant of any angle is equal to what? Well, secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. So then the secant of 30 degrees is going to be the hypotenuse, which is 2, over the adjacent of 30 degrees, which is root 3. And again, we'd have to rationalize. And we get 2 root 3 over 3. Okay, so probably should have labeled this is opposite, this is adjacent, and this is hypotenuse. Okay, if you haven't paused the video yet to do this third one, do so now. Otherwise, if you're lost, you can feel free to watch this one too. Okay, so I see that I want to find the cotan of 60, which means I'm looking at the 60, 30, 90 degree triangle. Now I have to fit in the 1, 2, root 3. I always do it as 1 is the smallest side, it goes across from the smallest angle. 2 is the longest side, it goes across from the largest angle, and then root 3 goes across the leftover or the middle angle. Now they want cotan of 60. Well, the cotan of any angle is the reciprocal of tan. Tan I know is opposite over adjacent, so cotan is adjacent over opposite. So now if I wanted to find the cotan of 60 degrees specifically, I would take adjacent over opposite. So which one's which? This is opposite, this is hypotenuse, this is adjacent. So adjacent is 1, opposite is root 3. So then I'm going to rationalize my denominator, and I end up with root 3 over 3. I picked 3 examples that you had to rationalize your denominator. Sorry about that. All right, so that is finding the exact values of special triangles. So we call these special angles because we know their exact values, and you should be comfortable with them. So 30, 45, and 60 should become your best friend. They're going to be throughout this course. All right, let's move on. Now what we're going to do is we're going to go backwards. So now that you have looked at finding the sine of an angle, or the cos of an angle, or the tan of angle, now we want to find the angle that gives us certain ratios of sides. So what we're going to do is we're going to draw the triangles again. So this says find the exact acute angle for the given function value. Now again, your choices are 1, 1, root 2, or 1, 2, root 3. So what I do is I look at the question. If I see a root 3, I'm choosing this guy, right? The 30, 60, 90 triangle. And if I see a root 2, I'm choosing the 45. So let's look at this first example. This first example has a root 3. So I'm going straight to my 1, 2, root 3 triangle. And you could even draw it to start. So if I know that I'm dealing with my 1, 2, root 3, I could just draw it in any format. You don't have to draw it correctly. So we're going to go across from the 30 is 1, across from the 90 is 2, across from the 60 is root 3. So what I'm looking for is which angle gives us a ratio of opposite to hypotenuse of root 3 to 2. Well, if I look from the 60-degree angle, this is my opposite side, and this is always my hypotenuse. So the answer would be that theta is 60 degrees, because theta to 60 degrees is the only angle that has an opposite side of root 3. All right, let's look at the other one. So this one, whenever they give you a number without a denominator, always put in a denominator of 1, right? The denominator of any number or any value is 1. So this is telling me that I have a ratio of opposite to adjacent of 1 to 1, which means I have to be looking at my 1, 1, root 2 triangle. So if I draw that, and you might not need to draw it for this one, right? This is going to be my 45, 45, 90 triangle. So this is going to be a 1, 1, root 2, and we check. No matter which 45-degree angle I look at, the ratio of opposite to adjacent is 45 degrees. So theta is 45 degrees. Okay, last one. So this one's a secant. It's a bit trickier. The first thing I would do personally is go secant theta. I would unrationalize it. So when you have a 2 root 3 over 3, that started as 2 over root 3. If you look at your formula sheet, I think I wrote a couple. Like I wrote 1 over root 3 is the same as root 3 over 3. And I think I wrote 1 over root 2 is the same as root 2 over 2. Just to remind you that this is a fact. Because when it's written as a rationalized denominator, it's harder to see the 1, 1, root 2 or the 1, 2, root 3. So you have to unrationalize it to see it. Now I can see this is like secant theta is 2 over root 3. Now again, let's figure out what this is saying. So secant theta, whoops, sorry, that did not write very nicely. Secant theta equals what is a ratio of what? It's a ratio of hypotenuse to what? Well, secant theta is 1 over cos theta. If cos theta is adjacent over hypotenuse, then secant theta is hypotenuse over adjacent. So I see the 1, 2, root 3 triangle. Let's draw it. Sorry, I usually do that first. I'm going to put 30. I'm going to put 60. I'm going to go 1, 2, root 3. The more you draw it, the more it'll be memorized. Now I have to figure out which of these triangles has which of these angles, sorry, has a ratio of the hypotenuse of 2 to the adjacent being root 3. In other words, which angle, 30 or 60 degrees, has an adjacent side of root 3? Well, it has to be 30. 30 degrees has an adjacent of root 3 and a hypotenuse of 2. So I know that theta would be 30 degrees. In saying that, if it's really confusing for you because the reciprocal trig functions are new, you could always look at that as, instead of being secant theta equals 2 over root 3, you could just take the reciprocal and say cosine theta is equal to root 3 over 2, and then you could maybe feel a bit better about it. Totally up to you, but it'll give you the same answer. Same answer. The answer, no matter what you do, is that theta is 30 degrees. Okay, so this is a section I gave you a lot more practice because this is super new. Okay, so I don't think there's anyone who comes in this course having seen special triangles before unless they've taken this course before. So I've given you 1, 2, 3, 4, and then a whole slew of questions. So when I give you this, only do odds because that's all there's answers for, unless you want more because you have the evens on the Moodle site and in your solutions manual. But practice as many as you need to feel good, right? Get comfortable with 30, 60, 90, 45, 45, 90, and what the sides are that are related to them.